Okay, today for the video, we're going to be analyzing the function f of x equals 2 to the power of x minus 4. We're going to be going through and we're going to be finding the domain, the range, the asymptotes of it, the x and the y-intercepts, the inverse of this function, properties of the inverse function. We're going to graph both of the functions and then find the relationship between the two graphs. Now to solve this, I actually like to kind of go out of order because if we do some steps first before other ones, we can find answers relatively easily. So we're going to start with actually graphing this function. So we're going to move to Desmos and pop in f of x equals 2 to the power of x minus 4. So there we have the graph, and right off the bat we can identify some key properties of the function and of this graph. So for the domain going left to right. This line, it comes from infinity. It has no end, and it continues on to infinity. It comes from negative infinity and goes to positive. So the domain is going to be negative infinity, positive infinity. Now the range, it goes from top to bottom. Range, it comes from who knows where, but you can see it doesn't pass this line. It keeps going this way, but it doesn't go down farther. It doesn't go past negative 4. Now, with these specific functions, it comes really close to negative 4, but does not cross. So it's not going to be a bracket, it's going to be a parenthesis. So it'll be negative 4 to infinity because, again, it's coming from the top. It's not going down. It's going up. So it'll be positive. Now, the asymptote is where the line will not cross. And it's kind of like the invisible x-intercept, but it's just farther down where it won't cross here. So that is right here, negative 4. So x is equal to negative 4 because it doesn't cross that line of the x. Does that make sense? Now we're going to find the x and the y-intercepts for this specific function. Now to find the x-intercept, we're going to set the equation itself equal to 0. So 2 of x minus 4 equals 0. Now to work through this, we're going to add 4 both sides. 2x equals 4. And then we're going to add log base 2, not add, but times it by log base 2 on both sides. And that's going to leave us with x is equal to log base 2, 4. Now, using the product rule, 4 is just a fancier way to write 2 to the power of 2. So log base 2, 2 to the power of 2, these 2's right here cancel out. The log base 2 and the 2 cancel out, leaving the exponent, which means x is equal to 2. To find the y-intercept, we're going to set x equal to 0. So 2, 0, so we're going to squish it in there a little bit, minus 4. So 2 to the 0 power is just equal to 1 minus 4 equals negative 3. Y, I'm going to move over here just for simplicity's sake, equals negative 3. Right there we have our x-intercept and our y-intercept. Now we're going to find the inverse of this function. Now to find the inverse of it, we're going to swap the places. F of x, as we know, is a fancier way to write y. So it's y equals 2 to the power of x minus 4. We're going to swap the x and the y, and it's moved to x is equal to 2 to the power of y minus 4. Make sure my screen stays on so we can keep this graph. We're going to be using this later. Now we're going to solve for y. Now we're going to add 4. So the x plus 4 equals 2 to the power of y. We're going to times both of them, both sides, by log base 2. I swear that says log base 2. And we're going to be left with log base 2 parentheses, that's important, x plus 4 is equal to y. That right there, I'm going to write that down. I'm going to move that right over here, is f inverse of f of x equals log base 2 parentheses x plus 4. Now that parentheses is important because if we didn't add that, then it would just tie the x to the log base 2, and it would be log base 2x plus 4, and that would give us an entirely different function. It's not the same. This right here is going to be the inverse. Now, to identify every other property that every other problem here, we're actually going to pop this, we're going to graph this inverse as well on Desmos. So, we're going to do f of x equals log base, if I can get there, it's hard to do this with one hand, 2 parentheses x, stretching my fingers, plus 4 parentheses. And as we can see here, we have a beautiful, it's the same shape. The green one is our initial function, and the blue here is going to be our new inverse of it. And we can see it has some kind of relations to it. Answering actually question 9 for the relations, if we go here to 0, 2, that's where the initial function crosses the x-axis. If we inverse the points of that, so instead of 0, 2, it's 2, 0, 2, 0, there it is, there's an inverse. Same property is 0, negative 3, right there. If we do negative 3, 0, negative 3, 0, interestingly enough, and the 2 and the negative 3 are actually our x and our y intercepts. Those will be used later. So we have found the domain of the initial function. We have found the range of the initial function, the asymptote of the original function, the x and y intercept. We have found the inverse function, the graph. We have graphed both the functions, and we found the relationships. The last step is going to be finding the properties of the inverse function. Now, the reason I left this for last is because we have actually already found all the properties of the inverse function. Because this is inverse of this, all the other properties are just opposite, if that makes sense. So the range for this function is going to be the domain of this function. So it's going to be negative infinity to infinity. The domain is going to be the range of this function. So it'll be negative 4 to infinity. Now, how do we know that for sure? Well, let's look at the inverse function. It comes from bottom and it keeps going up. It goes from the bottom, from negative infinity, and it keeps going up to who knows where. Negative infinity to infinity. And if the domain, it comes from negative 4, it does not pass that line, and it keeps going to the right. Negative to positive. Still lining up. The x and the y intercepts are swapped. Just writing it down. Sorry, I keep forgetting to keep it on. X-intercept is going to be negative 3. Y-intercept is going to be 2. And we already found that when we showed the relationship between the two. What else is there? The asymptote is going to be negative 4 as well. It's going to be a vertical asymptote because it's inverse. The horizontal is negative 4, and we can see here, negative 4 as well. It never crosses that line. And this is the function completely worked out. And there is the work done in order to find the domain, range, asymptote, x and y-intercept of this function. The inverse function is right there of this one. The graph of f of x and f of negative 1x is right here. The relationship is between, it's just shut off, but we did what we needed to do. And then the properties are all right here. It's just all this information is flipped on its head, and that's all right there.